The next article is the article by Albrecht Inhofe. And once again, just to share, this is not relevant for your test. Inhofe worked in Rayner's lab as a graduate student, got his PhD, and then actually moved to SUNY Binghamton. And I was a student there, and after a couple of years of being there, I ended up working under Inhofe, so my dissertation was under him. That's the way it kind of works in the academic pipeline of things. So this is a very kind of simple study that Inhofe has done, and he's probably nearing the age of retirement as well. But can anybody kind of summarize what did he do in this particular experiment? Taliban?
In trying to determine whether word frequency affected eye fixation.
Yeah, the idea of does word frequency affect eye fixation, and does it look like word frequency does affect eye fixation? Yes, that the higher the frequency of the word, what happens with your fixation time? Less fixation time on that, and what are you able to do more efficiently then? Where else are you getting information at the same time? So you're focused on this word in your fovea, the foveal fixation, but at the same time, what are you also starting to kind of pre-process a little bit?
The word to the right.
The word to the right, and you get that from what area? What is that area called? The parafovea. You're able to get information from the parafovea, and you're able to make eye movements, as it says there, to the right, and you can get information from that. So the main results showed shorter fixations on high frequency than low frequency words. Readers gained more effective previews from high frequency parafoveal targets than low frequency ones. So these saccades and these eye movements are all being tracked by eye trackers. In the late 80s, they were probably very old school. I imagine they have much simpler eye trackers now, but this is when I was in this research, and I haven't done this research since the late 80s, so kind of a little trip back memory lane for me. I actually knew all the people that are being mentioned in a lot of these publications because I went to some UMass conferences, and that's what you do when you're a graduate student in that realm. Comments or questions about this? See if there's anything else interesting, but I think I just focused on the abstract. So if you look at table 1 there, they just varied some things on the sentences to see how that would affect things. And it did. Higher frequency words, the fixation time would be shorter, and you would move to the next word, and if the next word had a high frequency word, you'd basically spend less time on it because you'd be getting a stronger parafoveal preview. So your eyes work basically by doing what? You're looking at a word, but at the same time you're getting what information in? Parafoveal information, and that's doing what to help you process? It's basically telling your eyes, here's where to move, here are the saccades, and here's how you process. The problem we had with the word from was that word was probably, there was top-down processing going on, the bottom up. Did some of you notice it was the word from there? Did you? Yeah, you actually noticed it, and it would cause you a lower fixation or a higher fixation time because it's like, wait, this is confusing. This could even explain sometimes, have you been in those experiments where they ask you to read a passage and there are words that aren't actually words, or they double letters and you don't pick it up? Top down kind of fills all that stuff in many situations. So that's the Inhofe article. Won't spend too much time on that, but Albrecht allowed me to get I earned my dissertation in his particular lab, so I am eternally grateful for that opportunity. Historically speaking, I think I told you guys this little story. I started off in the field of neuroscience, but got allergic to the rats that I was working with, and then went into psychoacoustics. Hand clapping was my master's. That didn't work out too well, and it was a blessing that I got to work with this person for my dissertation, and we actually got a publication out of that study I told you about, and launched me to get my first job at Rockford College in Illinois, where I said, reading and speech really don't interest me. I think I want to do asthma. But nice to go back on a little trip in memory lane. Okay, so that kind of covers it for that particular article. Let's see, let me put this on a little pause. Okay, so the next article that I wanted you to read, I'm just doing this for the acoustic version, is the Barber article, Parafoveal Perception During Sentence Reading. So the first question I wanted to check with here is, would you consider this to be a cognitive study or a cognitive neuroscience study?
Cognitive neuroscience.
Why would you say cognitive neuroscience?
Because they measured their cognitive processes with ERPs.
Brainwaves. We're measuring brainwaves now. The other two articles were much more in the cognitive realm. Here's how the eyes work, motor programs, here's how it's processed, but really the cognitive realm. So can anybody kind of say what they did and found here? What they did, what they found. Hannah, any thoughts on what they did and found here? Not really? Can your partner in crime help you out a little bit there, Lily?
My biggest question is,
Yeah.
Is Hebrew read from right to left?
No, left to right, actually. Boy, that's an interesting question. Nobody's
Well,
ever asked
it
me
just
that
said,
question.
Flanker words in the right visual field for English and then in the left visual field for Hebrew.
Yeah, Hebrew's actually read in the opposite direction. I just happen to know that because I'm Jewish. But I've been being a professor for 26 years, so don't worry about that. Just pretend we're in English here. So, Lily, can you help her out a little more with what they found here?
I'm a little confused because there's a lot of words in this that I'm just not familiar with.
Okay, so what
I don't really know what flanker strings and words are.
about pseudo words? Pseudo words. Does anybody know what a pseudo word is?
A word that's not real.
It's not quite real. Now I could give you the letters X, Y, L, P. You could consider that a pseudo word, but what if I gave you the letters M-A-R-D? Mard. Is mard a word?
Maybe in another language.
What's that?
Maybe in another language.
Yeah, mard is a good example. So if you want to write down a pseudo word, mard would be a good example. Why is mard a good example of a pseudo word?
Maybe because the structure of it, you can figure out what it says even if you wouldn't recognize it as
Yeah, it kind of follows. You got a consonant first and then a vowel. Kind of follows here's what a word looks like, but it's just not a word. So that's called a pseudo word in this particular situation. So they basically let people read and gave them, in the paraphobia, pseudo words. Now, what do you think would happen when you gave somebody a pseudo word? So on the bottom of the door, there was a mard. If you want to write that down, bottom of door, there was a mard. What do you think would happen to people when they were staring at or was a? You kind of get that parafoveal preview in there. What would happen when they actually got to the word mard, though?
They'd probably be confused.
From and for. So what would happen with fixation time?
Probably be longer.
Longer fixation time in that situation. So that's what they were interested in studying. Now that's the cognitive realm, but if we read the abstract, they basically found that when words or pseudo words or incongruent words, marred if you will, or on the bottom of the door there was a chair, chair might be what? You wouldn't have a chair on the bottom of a door, would you? Or you could say airplane if you want. That would be an incongruent word. What did they basically find here? It would be slower, number one, but what else did they report here that makes it cognitive neuroscience? They would be measuring the electrical activity in the brain and recording things, and they would see what happens when these pseudo or incongruent words were shown. Says here in the sentence, starting with P2 waves, so waves at 175 to 300 milliseconds were less positive if they were incongruent or even pseudo words. So you'd see differences in brain waves. So we've got differences in cognitive activity and differences in brain waves. So this makes us a cognitive neuroscience type of study. Let's see what else we got here. I pointed to a couple of other highlighted pages. Page 2. Yeah, they talk about the electrophysiology signatures of words in the paraphobia. And the basic idea here is if you go to the bottom of this page, they talk about event or eye fixation related potentials. Yeah, that's actually what it is. That if the lexical status changes from a word to a non-word, so marked to marred, that's going to show some problems with waves in the brain. It's going to be a longer fixation and something's going wrong. Notice what they say there towards the bottom, predictability. If you can predict the word, those waves will be normal, fixation times will be shorter. So this is kind of taking the reading research and doing what with it?
Physiological context.
Yeah, kind of the electrophysiology context of what's going on in the brain. So the other page I would have you turn to is page 8. If you never know where to go in an article to figure out what do they find, where do you go? Could you read the abstract? You could, but if you really want to know what they found, where should you go? The beginning of the discussion is supposed to be a summary of what they found. So let's take a little look at that. The present study explored the processing of words in the paraphobia. We'll just say English sentences and ERPs. We looked at all these different things. We manipulated things. So on the top of page 9, the amplitude of the P2 wave were larger when it was congruent than it was incongruent. So this is kind of what they do in cognitive neuroscience. They look at brain waves and they're looking at the brain waves as you're reading. So does that make sense for folks? Okay, that's article number X. What did we have? Article number 4. So I'm going to ask people now to pull up the Gabriella article on dyslexia. We'll stop this recording here.